Okay. So, and just as a reminder, if there's anything that I mention when I'm going through an explanation here, feel free to ask questions if you don't understand, and possibly if you do understand but you think that other people might not understand, bring that up, and I can go over a specific section a little bit in more detail. So, today we're talking about logarithms. And I'm going to redraw that M. And so the big thing with logarithms, that the reason that I wanted to talk about it is because it seems like a lot of people that aren't in math-oriented situations, like if in the arts and whatnot, a lot of people who just have a maybe algebra 1 or college algebra schooling on math tend to just not understand logarithms. And I mean, that's nothing on those people. It's just that logarithms aren't necessarily something that we use on a daily basis. So it's not, people tend to not really get a grasp on it when they're initially taught. So I just wanted to kind of explain it in hopefully a new light compared to what people might have gotten in school. So essentially, first off, let's start with a math problem that's pretty simple. So if we have a problem that is some number, so we're going to say 7 to the 2 equals what? Okay, so this is a pretty simple math problem. We have a number, we're squaring it or putting it to the power of 2, and we want to know what the answer is. So most people can square numbers, or it's pretty easy to do on a calculator. So this is 7 times 7, it's 49. And that's what this equals. So this is a pretty simple math problem, but this is a power function. So if f of x equals some number to the x, that's a power function. And so and then f of x would be our answer. So what logarithms are is somewhat of the same thing, but a little bit different. And what I mean by that is it's a confusing topic because we're not necessarily talking about an entirely new topic from this equation. We're actually just moving where the question mark is, essentially. So a logarithm is basically saying 7 to the what equals some number equals 49. And so this would mean that the answer is the answer we're looking for is actually the power that we're dealing with. And the way that this problem would be written out in a logarithmic syntax is log base 7 of 49 is equal to 2. And so this means that 7 to the power of 2 equals 49. It's the same thing as this equation up here, but it's a little backwards, and that seems to be where people tend to trip up. So this is an interesting idea because this means that this logarithm, log 7, is actually the inverse, or the, I guess you could say the inverse of 7 to the x. So if we have log 7 of x, right? And we multiply that by 7 to the x, then, sorry, I'm doing this wrong. If we have log base 7, and we take the log base 7 of 7 to the x, then we should get x, right? Because if we have, this is essentially log base 7 of 7 squared. So this would be our x term, and it becomes the answer. So that's basically what a logarithm is, and I want to explain a couple cool things that you can do with logarithms. So with a logarithm, like I said, you can have really any base So here's the base, here's the number you're applying it to, and here's your answer. So this base can be anything you want it to be. But what you'll see is on a calculator, if you were to be using a logarithm, then you would usually see two things. You'll see log and you'll see ln. And so I'll just explain what these are right now. Log is actually log base 10. This is just something that is used commonly. It's usually kept on a calculator. I have mine here, and you can see. Well, actually, it's kind of scratched off, but this button right here says log for logarithm, and then right under it it says ln, and ln is actually log base e, and so then you'd be asking, what is e? Well, e is actually the Euler number. If you know the number pi, it's somewhat like that. It's just a constant that comes up a lot in math that we use. This is actually equal to, I believe, 2.718 ... as in it continues on forever just like pi does, and there's no repeating pattern to it. So log base e is the natural log, because e actually comes up a lot in natural occurrences, but there's some cool things about e. The derivative of e to the x is so de to the x over dx is equal to e to the x, and it's the same for the integral. Its slope is the same as the position that it's at. So it's a little weird, but so these are the common things that you'll see, and that's what you can use on your calculator usually. Now, some fancy ones, if you get the Inspire or the TI Inspire or anything like a TI 89, they tend to have a log base function where you can plug in whatever base you want. But there is ways to use other bases when you only have a simple calculator. So if you have log base 10 to work with, then so this is just log. So what you can do is there's a change of base formula. So if you want to have your log base 7 of 49, but all you have is log base 10 to work with, then what you can do is you can say log of 49 divided by log of 7, and that should be equal to your answer. I'm actually going to try that out for myself just to make sure that I'm not blowing smoke here. Divided by log of 7. So that gives us 2, which is what we said that the answer was. This works out because there's some funny stuff that happens when you divide logarithms. It's actually somewhat like subtraction in a sense. I might have that backwards, but I'll save that for another day. But this is basically what I wanted to talk about on logarithms. So if there's any questions, I'll either answer them before I get into the next topic, or if I see them late, I'll answer them at the end of the stream. But with that being said, I think we're going to be moving into my second topic, which is the Alford-Kinsey scale. So I'm going to clear some stuff up and get another sip of water.